For section 8.1, we're going to talk about similarity in right triangles, and we're going to start off with a theorem. And that theorem says that the altitude to the hypotenuse, so the altitude that we have to pay attention, there's three different altitudes. It goes from an angle to the opposite side, but this one has to go to the hypotenuse. So we're going to talk about the angle opposite of the hypotenuse, the length going from that angle out to the hypotenuse. So it always has to be that same altitude. And that altitude of a right triangle forms two congruent triangles that are similar to each other and to the original triangle. So there's the large triangle there. Then when we draw the altitude, it splits it up into two smaller triangles. And this theorem is saying that all three are similar, which means they would all have a similarity ratio that's the same. So for example, 1, we have to write a similarity statement comparing the three triangles. So let's start with the large triangle. And we're going to call that one JLK. So I started at the 90-degree angle, then I went the shorter leg, and then out the longer leg, or the hypotenuse, I guess it is. And then that one is similar. Let's do the medium triangle. And I have to start at the 90-degree angle of the medium triangle, so that would be M. And then the short side would be J, and then go down the hypotenuse to K. And then is similar to the small triangle. Again, we have to start at that 90-degree angle, which is M. And then to the short leg would be out to L, and then down the hypotenuse would be J. So that is our similarity statement comparing those three triangles. Next is a vocab word. It's the geometric mean of two positive numbers that are A and B. We take the positive square root of their product. Remember, there's always two square roots of a number, positive and negative. In this one, we're going to focus on just the positive version. So this says that the geometric mean is A times B, and then we take the square root of that. So for example 2, we have to multiply the two numbers together. So 4 times 9 is 36. And then we have to take the square root of that, which is 6. So it's just the positive answer. And then we have to do 6 times 15, which would be 90, and take the square root of that. Now this one is not a perfect square, so we have to break it down. We have to simplify it. And 90 is 10 times 9. In 9, the square root of 9 is 3, so it goes out front. And then we have the square root of 10 left. And then double check. 10 breaks down to 1 and 10, or 2 and 5. And none of those four numbers are perfect squares. So this would be our simplified answer as far as we can break it down. This picture here is just showing us the different similarity ratios that we can come up with. So the first picture is of the large triangle, and it's saying when we take the side length B over A, so the bottom leg here over the top, the side leg, that's terrible, but that's what we're talking about, is equal to, in the medium triangle, the Y over the H, and then on the small triangle, the H over the X. So the similarity ratios of side lengths on each triangle compared to the other ones that are left. So they always start with the large triangle. So then the middle one says C over A. So that would be that long side, that hypotenuse side there. Both X and Y added together is C over the short leg. So that would be in the middle triangle, the hypotenuse over the short leg, which is B and H. And then in the little triangle, the hypotenuse over the little side, the little leg, which is A over X. And then the last proportion down here says C over B, which is the hypotenuse over the longest leg. And then in the middle, the hypotenuse over the longest leg would be B over Y. And then in the small triangle, the hypotenuse over the largest leg would be A over H. So just showing the different ratios that can be set up to the similar triangles. So now we have these two here. You're going to need this picture and these three equations to help you solve problems. So it says the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the two segments of the hypotenuse. So we know that the altitude squared to the second power is equal to x times y. So If we knew a couple of those lengths, we could find the third length, and that's what we're going to have to do. And then the second one says that the length of a leg of a right triangle is geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So a squared is going to be equal to x times c. So that short leg times the whole hypotenuse of the large triangle. And then b squared, which is the longest leg of the big triangle, is equal to y, which is the longest leg of the medium triangle, times c, which is the hypotenuse of the large triangle. So we need that picture so you know where all the letters are, and then you need those three equations so that we can plug in the numbers that we know. So here, example 3, we need to find u, v, and w. So the altitude is h. So right now I know that 9 equals h. And maybe if I label them, oops, I'm going to put h here. And that 3 is that smallest leg of that little triangle, which in our picture would be x. So 3 equals x. So I'm going to put an x behind it so we know. And then if that's x, the u has to be the y. So this is really y. And this whole thing here would be c. And then the shortest leg of that long triangle is A. So V would be really A. And the longest leg is B. So the W would be B. So the pictures aren't going to look exactly like that one in the theorem. So we have to figure out where they all go. And that would be your first step. Just figure out what letter represents the ones from this picture. So now because we know h and x, look at the three equations. Which one has h and x in it? Well, it's that top one. H squared equals x times y. So we're going to use that. H squared equals x times y. So we know h is 9. So 9 squared equals 3 times y. So 81 equals 3 times y. And then we divide both sides by 3. We get y is 27. So now we know that y is 27, which is really u. So u equals 27. So we have one of our answers. So now I'm going to put 27 here. So now we have h, x, and y. So if I go back up here, I don't have, we have already used h squared equals x times y. So those other ones, I don't have one of the other two equations that have an h, an x, or a y. So 2 out of those 3. So I'm going to look back at my picture. Now that I know x and y, I definitely know what c is. So that entire length would actually be 30. So 30 equals c. So now I have a c. So now I need to use that information to find a and b. So a squared equals x times c. So let's do that one since I know what x and c are. So a squared equals x times c. So we don't know what a is. X is 3 and c is 30. So a squared equals 3 times 30, which is 90. To cancel out a squared, we have to take the square root. So a equals, and remember 90 is 9 times 10. The square root of 9 is 3, and then we have square roots of 10 left. And looking on our picture, a is really our v value. So v, I guess they kind of look the same, that's a u. V equals 3 square roots of 10. And then our last one, b squared equals y times c. So b squared equals y times c. So b we do not know yet. Y is 27 and c is 30. So b squared equals 810. And the square root of 810 is not a perfect square, but it would be 81 times 10. So we'd have to take the square root of both sides. So b equals the square root of 81 times 10. The square root of 81 is 9, and then we have that 10 left over. And b is actually our w. So w equals 9 square roots of 10. So these problems are going to take you a few minutes to go through and figure everything out. But it starts to come together as you find a couple of the numbers. All right, example 4 says a surveyor positions himself so that his line of sight to the top of the cliff and his line of sight to the bottom form a right angle as shown. What is the height of the cliff to the nearest foot? So looking at this picture, I need to figure out this whole piece right here, which would be our C. So the whole goal is to figure out what C is. So remember, in our triangle, the shortest side back here is x, which we right now know is 5.5. So x equals 5.5. H is our altitude. So right now we know that h is 28. This longer leg here, this piece is y. Our short leg is A, and our longer leg is B. So we need to figure out what x plus y is. So before we can do anything, we have to figure out what y is, since we already know what x is. And we know h and x. So back in that chart, we can do h squared equals x times y. So h is 28. So 28 squared equals 5.5 times y. And 28 squared is 784. Then I would have to divide that by 5.5. And I get 142.5. And it says to the nearest foot, so we're going to say 143 equals y. So if I go back up here and label that, this is 143. Maybe we need to put that 0.5 on there for right now, since the other one's still in 5.5. So to figure out the total height, we add the 143.5 and the 5.5. We get 149. So what is the height of the cliff to the nearest foot? 149 feet.